Welcome, everyone. Getting some feedback here. Hold on one second. Welcome, everyone. Getting some feedback here. Yes, if that's going to take care of it. If not, I'll get a call from IT real quick. Okay, let's try this one more time. So we just had some work done on this room this week. So this is kind of a couple of new things. So again, welcome. My name is Crystal Hopper-Myers, and I run our STEAM Pathways program here at SWOCC. If this is your first time here at SWOCC, I welcome you and also encourage you to kind of walk around Umpqua Hall and check out the labs and all the classrooms we have here. We're really proud of this building and grateful for the community for providing it for us. So here's IT. Hold on one second.
Hello, live streamers and audience. Okay, it's just feedback.
Yeah, this me.
Okay. You fixed it?
I mean, it was such a big deal. Let me tell you, it was really complicated. So, you know, thanks. So anyways, I just wanted to kind of open up and we try to share a few things about our STEAM Pathways program here at SWOCC. We have a lot of exciting things happening. Today is actually our final lecture of the fall term with this physics lecture. That's going to be really exciting. Here in just a minute, I will have somebody come up and introduce our guest. One thing I always like to kind of talk about is we have an awesome team of student researchers. The name of that team is SPEAR. And we currently have about 9 students working on a project involving Fossil Point, and that is led by our geology professor, Dr. Wynn McLaughlin over here. We have, yes. We have some of our students here today. And then if you're also a student currently, or if you're listening or later on, you're watching this on YouTube, if you're interested in getting involved in any of this research, please reach out. Our offices are right here. Dr. Queener and I, and actually any of the professors will be able to help connect you. We have a lot of cool opportunities to actually get paid, like a paid internship while you're doing student research, which is some really great hands-on experience and things that you can fill out on those scholarship applications and your future CVs on all of these great experiences. We always like to say thank you to our Oregon NASA Space Grant Consortium, which has funded that project that I was just talking about, and many others. Also, recently, we started another program, teamed up with the Oregon Coast STEM Hub to help start a program called the High School STEM Internship. That's for students 16 years and up. I actually had another one today reach out to me, and we have a couple of them working on some projects right now. One of them is actually a student that had previously was with Winter Lakes, now doing our GED program here, and she's looking for micrometeorites with our Starfall project, and another one that is kind of working on having to do with how micrometeorites affect plant growth. So again, it's just awesome opportunities like this for students here. We're always really excited to talk about that. We have just the other day, I was down at our Curry campus in Brookings with a planetarium show. We've got a portable planetarium that we kind of travel around. We try to do a lot of the K-12 and community outreach. So if you'd like to ever learn more about that and you're on social media, go to our Facebook page, SWOCC STEAM Pathways. We also share information on the website at SWOCC.edu. We have an opportunity at the end of this presentation to ask questions, and we'll walk around with the microphone so you can ask those questions. Just raise your hand and we'll get to you. I believe my son Wade's actually going to help me with that. And so I hope you enjoyed tonight. And right now I'd like to ask Dr. Aaron Pointer to come up. He runs our physics and engineering department here at SWOCC. And he's going to tell you a little bit about our guest. Thank you.
Thank you, Crystal. Without your work and the work with the SPEAR team and the rest of the faculty, very few of these things, including the lecture series, would be possible. So we thank you for what you and what everybody else is doing to help facilitate these things. I'm fortunate today to get a chance to introduce one of my esteemed research colleagues, one of my best friends since grad school, and one of my fellow grad school sufferers at Rice University, Dr. Roman Gomez, senior scientist at SWOCC, which if you're not familiar with SWOCC, that's the Southwest Research Institute. They have campuses at San Antonio, Texas, and in Boulder, Colorado. I don't know if you've got a third one yet, but I'm sure, but I know you're based out of the San Antonio one, because we can't pull you out of Texas other than for a week or two, but we are glad to have Dr. Gomez coming in. His day job, he likes to calibrate instrumentation that goes up into space. So, but every once in a while we decide to let him have a little bit of fun, and one of his other hobbies is the enjoyment of and propagandizing about anime. And we ended a lot, and this particular talk basically lets us kind of merge the streams of academics and talking about physics, and then the fun side of talking about anime, comics, and all kinds of other fun things that we tend to tie in just to keep ourselves sane when we're dealing, because if we do science for too long, the sanity becomes questionable. But I am more than happy to introduce my good friend, Dr. Roman Gomez.
All right, can everyone hear me? Yes. Okay, I can't stand microphones. I'm sorry. It's try to have an aversion to them. So yes, as Aaron stated, yes, we had a shared trauma experience at Rice University, also known as getting PhDs there. And it's funny, and Aaron mentioned this. I sometimes wonder if I give this talk to talk about physics in terms of anime, or to talk about anime in terms of physics. It's usually kind of like the same question: is light a wave or a particle? And the answer is yes. So let's just go with that. So let's see if this thing's gonna work for me now. Oh, there we go. All right, well, there we go. Okay, so just a little bit about me. Aaron mentioned this. This is Southwest Research Institute. It is the main campus is located in San Antonio, Texas. And this is all a lie, because right now everything is brown in Texas. We're just getting out of our summer. Okay. We are currently we are the largest not-for-profit research facility in the United States. We have a number of different divisions: space science, defense, and intelligence. And in the space science and engineering division, we have a space plasma physics division, in which case I am an experimental physicist. At that point, I help building ion optical systems for plasma instruments. And that's normally what I work on. So this right here is something called the solar wind plasma sensor, SWIPS. This instrument is actually quite small. I mean, I could hold it in my hand and still have, almost have my fingers touch. It's very, very small. The reason why is because this is going to be sampling the solar wind. And as we know, lately we've had a very, very extreme solar cycle, a lot of coronal mass ejections, a lot of solar flares, and these kinds of things need to be measured before they hit us. We'd like to know that something's coming our way. And so this is essentially the last line of defense. This launches next year, and it will be the primary solar wind sensor from 2025 to, I believe, 2030 is the primary mission. The other instrument I work on is something called tracers. This is a one-off from another instrument I've worked on. It's called MMS HPCA. Again, I helped develop the optics on this. They're actually heritage optics, something we worked with before. You know, if something worked before, we kind of stick with it. These will be flying very, very rapidly at about I think it's 590 kilometers above the surface of the Earth. They'll be making about 18 orbits every day. And during that time, we have to look in when they are crossing the what's known as the northern hemispheric cusp. So it's a region where you have magnetic field density, but they're kind of where the lobes are. So we'll be looking for signatures of magnetic reconnection. So now that I've bored you, you know, the honest goodness thing is that all work and no play makes Roman a very, very dull boy. I don't get me wrong. I love designing ion optical instruments. But I have a penchant for reading comic books. Ask my wife. I've got a whole slew of them. And there is some truth to the myth that it's not actually a myth. You know, I know Aaron and I on numerous occasions sit around at lunch and talk about which DC superhero could beat which Marvel superhero and vice versa. We actually do talk about things like that. So if you've ever wondered. But another one of the things that I got into early on was something called anime. And I'm 54 years old. I've been watching anime since I was 8 years old. So any anime watchers in here, raise your hand. Ah, yes, you're good people. So what started this off is I teach a class at St. Mary's University called the Physics of Superheroes. I find that when you say physics, most people shut down immediately because, you know, usually kind of soul breaking, okay? So what you do is you put a little teaser in there. You say, well, you know, let's talk about Superman. Let's talk about Superman and Superman 1938 Action Comics #1. He could not fly. He could not fly, but he could leap tall buildings in a single bound. And so you're like, okay, how does that happen? Well, let's talk about Newton's 3 laws of motion. So the nice thing to do is let's throw something in there that's kind of a misdirection and see what comes out. And I mean, a telling thing for me was a student who I had at St. Mary's told me that she despised physics in high school. And at the end of the semester, she was actually sad that my class was in. So to me, that was a telltale. In 2017, I attended my first anime convention. Yes, I was a late bloomer on that day. You know, at least I did. And sure enough, I realized, hey, you know, I could do a panel that does the same kind of treatment as the physics of superheroes. And that's what it's. So what I'm going to talk about tonight, we're going to talk about Einstein's theory of special relativity, what happens if you move near the speed of light. We'll talk about quantum mechanics, another one of my faves if you're into that sort of painful thing. Ooh, so good. And then we'll talk about a few other things to kind of wrap up. Now, the idea is physical principles represented in anime. If you allow for certain exemptions, allow for certain things to, you know, like massive objects traveling close to the speed of light or achieving the speed of light, then the question is, are the physical principles properly represented? That's the whole idea behind it. And if you allow, then I'm going to go ahead and say this all right out, you know, just make myself hated. All science revolves around physics. You know, the way it goes. You can take it up with me next time. All right. So, is it far-fetched to think that you can have anime that accurately represent physical or scientific principles? And the answer is no. There are actually some really good examples out there. For instance, Cells at Work 2018. You can actually use this anime to teach children about how their bodies function. The only problem is this. Those white blood cells are absolutely murderous. So you have to find some way to kind of, you know, tone them down a little bit. Okay. Another one that's excellent is Dr. Stone. Anyone watch Dr. Stone? Yeah. Dr. Stone was great. Okay, Dr. Stone was great. All the physical and chemical principles were spot on. As a matter of fact, I actually learned something from Dr. Stone. There's a part where Senku is making a light bulb, and he does not used a tungsten filament. Does anyone remember what he used? What did he use?
He used bamboo.
That's right. He used a piece of charred bamboo. See, a lot of people don't realize this, but carbon is conductive. And believe it or not, when Edison made his first light bulb, he used a piece of carbon tape. You actually get that directly from the unit. But that's not what we're talking about here, right? We're not talking about anime that specifically talk about scientific principles. We want to know if something looks far-fetched, how far-fetched is it? Is it spot on? Is it described in a reasonable manner? And that's what we're trying to tease out here. Okay. All right, so the first anime that I'm going to talk about is something called Gunbuster, Aim for the Top. So this is a really old anime. Not yet. Lights a little bit? Dimming the lights? I have no idea how to do that.
We actually have online works and the it just was like this, yeah. Sorry.
No, sorry. All right, yeah, so this anime is started in 1988. Now, this was the directorial debut of Hideaki Anno of Neon Genesis Evangelion, one of the greatest anime series ever made. Absolutely amazing. There's always these existential threats. In this case, humanity is under attack by a race of insectoid aliens. And then we have a protagonist, Noriko Takaya. She becomes the pilot. There's a lot of trials and travails. She becomes the pilot of this Gunbuster fighting robot, which is so amazing because it can actually take out an entire armada. I need to build something like it immediately. So the really neat thing about these anime is that at the end, they have these science lessons. And they're little short blurbs, and they actually mention some interesting scientific, principles. So I'm not going to show the first video, but I'll show the second video. But in the first video, Noriko mentions two things. One, space is not an ether field, or space is an ether field, which is not true. And that space is about 3 degrees Kelvin, which is true. So there was something called the Michelson-Morley experiment, conducted at the turn of the century. And this actually established the constancy of the speed of light in a vacuum. Okay, it showed that the speed of light had no preferential direction. So space being an ether field, that's definitely not true. But space being 3 degrees Kelvin, that's pretty close to true. And I'll talk a little bit more about that in a bit. She also introduces Newton and Einstein in this one and says, well, they're his predecessors, their bygone era, because there's this new big brain called Tannhauser who's won the Nobel Prize 5 times. There's only been, I think, one person that's only won the Nobel Prize twice, maybe 1 or 2. And the going rate for a Nobel Prize is about $1 million. So not only do you get immortality, but $1 million. So $5 million. There's probably inflation big time because this is in the future, right? So it's probably banking. So what about this whole space is about 3 degrees Kelvin or 3 Kelvin? It has to do with the fact that the universe had a universe originating event called the Big Bang, approximately 13.8 billion years ago. And 100,000 years after the Big Bang, the universe was radiation dominant. You're essentially having gamma rays flying all over the place. Well, as the space in which those photons are propagating is expanding, they have to expand along with it. They're limited to traveling in space-time. And so what was a gamma ray photon at the Big Bang is now being redshifted or elongated in this kind of respect into what we see as a microwave photon. So again, we see the cosmic microwave background. Hopefully you can kind of see it. This is what it looks like when you're looking in space out in the universe, see the cosmic microwave background. And you're like, well, that looks like some giant yin-yang symbol in space. And that's not really what's going on here. That has to do with the relative motion of the Earth in space. This is plus or minus 6 millikelvin, which is 6,000ths of a degree Kelvin. I got my PhD in astrophysics from Rice University back in 2011. But the first time I heard about the cosmic microwave background was from this anime, which is really, really cool. So obviously, Noriko is doing her homework. Penzias and Wilson won the Nobel Prize for this particular discovery in 1978, and it was by accident. They actually thought that it was radiation from pigeon droppings that were nesting in there. They actually cleaned it out and found that they still found the radio signal. Lo and behold, they found the cosmic microwave. Now, I'm going to show you this video. This one here talks more specifically about light speed. So let's see how Noriko and her buddy and their coach talk about this. And are we gonna play it? Oh, there's no audio in here, apparently. Is there a volume? Oh, wait, here it is. I didn't hear it. No, I don't think it's gonna be able to. Oh, okay. Well, all right. Well, darn it.
And then if you're not talking.
No, that's, I still get the feed. No, I don't think it's gonna be able to. Okay, well, darn it. Let me see if I can fast forward to, no, it's not gonna allow me to start forward. Fast forward. Okay, so let me, as they're talking through this, they're gonna go over a few principles, something called the Hiroshima effect, which is what we call is time dilation. So the faster you are moving, the slower you experience time, or your clock ticks slower. We'll get to more in a little bit. Then we got the Doppler effect, an apparent change in wavelengths of light. This is what I wish I could do when students were falling asleep in my class, that I could just like, have this giant head. So unfortunately, we don't have the audio, but as you can see, we, just like any good anime OG, I actually have subtitles, it's the way to go. But the interesting thing is all the equations in that video were absolutely correct. So I think we've got, so let's kind of move forward. So there's a few things we need to know about light speed. So Einstein's theory of relativity has some really interesting implications. So one, Einstein's postulates, the laws of physics are invariant in all non-accelerated reference frames. So that means if I'm standing still or if I'm moving at a constant speed, I'm going to see the laws of physics the same. Now, if I'm in an accelerated frame, then we have to talk about general relativity, and nobody wants to do that because it's painful. Two, the speed of light in the vacuum is the same for all observers, regardless of the motion of the light source or the observer. What we say is the speed of light in a vacuum is a constant, and it's actually the speed limit. That is the universal speed limit. We have never seen anything move faster than that. And there are, again, some other effects. So there's mass energy equivalence. We know this E equals mc squared. If you ask someone what's Einstein's theory of relativity and they answer E equals mc squared, they're wrong. It's an effect. It's an effect of Einstein's theory of relativity. And it's actually kind of misleading. This is, if you take particle physics, this is E squared is equal to B squared C squared plus M squared C to the fourth. Now this right here is the rest energy. This is the energy you simply have by what we would say being a particle. But this right here is something known as that kinetic energy. And so that's something that we normally will increase. So like when we're playing games at the Large Hadron Collider, we take these particles and we accelerate them to 99.999% the speed of light, and then we smish them, which is a scientific term, smishing these things into each other, and we try to see what comes out afterwards. Right? Because we know that energy mass equivalence. This kinetic energy that I have in my initial phase can lead to a more massive particle, and that's actually how we found the Higgs boson back in 2012. But how about this constancy of the speed of light? So have you ever wondered what it's like to travel at the speed of light? I mean, believe it or not, you're doing it right now. You are. It's just that when we talk about the speed of light, we're talking about a velocity. And so a velocity has a magnitude and a direction. So if right now, as we are sitting, we're moving at the speed of light, but we're moving in a very time-like fashion. Our velocity is directed in a very time-like fashion. I never really move fast enough to get significantly off this time axis. But if I can somehow find a way to travel at a faster speed, then I make my motion more space-like. So anytime you're moving, so this would be an incentive to like start running, right? Anytime you're moving, you're aging slower. If you drive in a car at 100 miles per hour, you're aging slower than you would were you standing still. But if you get pulled over by the Oregon, I guess, State Patrol, and they ask you, what were you doing? I was trying to age slower. I'm sure they would say, well, that's commendable, but please, pay your fine. I guess those are some of the consequences of traveling fast. Now, and again, the way this stuff works is you cannot move faster than the speed of light. That's what these light cones are here. So being out on this cone is the fastest that any kind of information can be transmitted. So you're born in the past, some say supernova explosion occurs, but that light is still traveling at the speed of light. And so you won't see it until those two, your time axis and that space-like axis or that velocity coincide at some hypersurface. That's what's going on. This is a lot of fun to talk with, and when I introduce it to my students in astronomy, I can see their minds slowly breaking, which just gives me great joy. So, okay. So again, what's the problem here? Also, massive objects cannot achieve the speed of light. They can get close to it, but this is what's killing us right here. So this 1 minus v squared over c squared term, you're like, you promised no math. No, I didn't say anything about that. So what ends up happening is as this approaches the speed of light, this approaches unity. Then I've got a 1 minus 1, which is a 0. And I start taking the square root of 0. And it's always so funny. What's 1 over 0? And there's 1 0. No. This is infinity. It blows up. It's a singularity. It's telling us that we don't have the mathematical understanding yet. That's exactly what this is telling us. But for right now, this is the best thing we've got. So achieving higher velocities means you have to put more energy into it. And in order for you to get a massive object to achieve the speed of light, you need an infinite amount. And as far as I know, we don't have any infinite amount. Not even fusion for us. There's two situations in Gunbuster that they really paid attention to. So one, there's a situation where Noriko she has not seen her father for 7 years, but she actually encounters him on the ship on the bridge of his ship, and only 2 days have passed by. And if you do the mathematics, this is how almost the speed of light, almost the speed. So, again, yes, like some nerd, I was like, oh, let me go ahead and calculate this. That's exactly what I did, so you don't have to do it. Another example, you have a 12-second delay resulting in the passage of 6 months on Earth. Noriko's on a mission. She, again, has a 12-second delay, and she saw her friend. She was 3 months pregnant. Immediately after this, she goes back to the Earth, and her friend's daughter is old. So she kind of missed it. She wanted her to be there. It's kind of a coming of age anime. It's a lot of fun. But again, the reason why I picked on this one is because they put the principles right. And that's the whole point. Now, if you could travel faster than the speed of light, Star Blazers actually had a situation where they treated it exactly correctly. So there's this episode 8. And what they do here is they basically warp directly from Earth out to as far away as the Sirius star system, which is 8.6 light years away. But 7 years prior, the Gamelon Empire bombarded the Earth and turned it into a radiated wasteland. But again, it's funny. If light has a distinct speed, right? It's the speed of light, and it's always going to travel at the speed of light. So if the Earth was pummeled 7 years prior, then that light from 7 years ago has only gotten to a certain point. That means that the light that is emanating from that point on still sees the Earth as it was. I think that's a fascinating thing, that whenever you're looking out in space, you're looking back in time, right? When you look at Betelgeuse, however you choose to pronounce it, 635 light years away, you're seeing the light that left it 635 years ago. That star could be dead. But we won't know. It could die tonight, but we wouldn't know. And, take multiple generations until they actually saw that concept. So I always thought that was something fascinating, and I thought it was cool that they actually treated it correctly. Now, this is a great anime. Anyone ever watch this with Steins? Okay, so Steins starts one whole way, and then you're like, how in the heck did I start this, and why is it hurting me so much? Okay. I mean, this is a really good anime, but you start the ride, you might as well finish it. So it's from the visual novel of the same name. It follows these exploits of this guy, Rintaro Okabe, but the real brains is right here. He's the smartest person. They find a way to send messages into the past. They call them D-text or D-mail messages, and they're actually able to manipulate the past and have it affect the future. And in doing so, they attract the attention of CERN, S-E-R-N, which is based on CERN, C-E-R-N, and of course their troubles really, really start. So when I was trying to decide whether I was going to go to Southwest Research, I also had a chance to go work at CERN. And sometimes, you know, the thought of working for an evil empire, you know, that would be really cool. But oh well, you know, we'll talk about more in just a little bit. Okay. So first off, time travel. Okay, time travel backwards is more than likely, highly unlikely. Okay, the majority of the scientific community thinks that that's pretty much right. Okay, it violates causality. You know, nobody wants to become their own father. This kind of stuff. You know, then you get to really gross stuff. Okay, forward time travel. We just talked about that. Travel really, really fast. Like say, for instance, you know, tax season is coming. And if you could find a way to travel at the speed of light, you know, it just for maybe a year, you know, maybe 1,000 years would pass by and maybe the IRS would be gone. But with your luck, they'd probably still be around and you just owe 1,000 years of back taxes, you know, so. Again, a better idea is just to camp outside the event horizon of a black hole. As long as you don't go in, you'll be fine. Okay, just you know, understand that the IRS will still be around. It's just the way it is. Now, there are snippets of the community that think that there may be traversable wormholes, but that's getting into a whole other bit of mess. The jury's still out on everything. But what we do learn about in this particular anime is there is a particular character who keeps dying. I think her name is Mayuri. And she's very beloved, and the protagonist doesn't want her to die. But what happens is he's in a timeline where she is destined to expire. And so what he has to do is he has to move to another timeline where she stays alive. And that's what they spend the second part. I'm sorry if you haven't seen it. You know, still watch it. It's really good. If I've ruined it for you, I apologize. But there's this idea of, are multiple world lines a reality? This is where quantum mechanics. Okay, so quantum mechanics is a really, really pesky theory. It will never give you a straight answer. It will give you kind of a fuzzy answer. Well, here's the probability. Here's the possibility of, but it never gives you a straight answer. It's really fuzzy. And again, the thought experiment, and this is a thought experiment, not a real experiment. If you do this experiment, you're a horrible human being. Okay? The Schrodinger's cat experiment is a thought experiment. And you know it, you get a box, you put, you know, some kind of decaying atom in there, you have some source of, you know, poisonous gas, and then you put these all in there with the cat, and then you close the box. And then you ask the question, is the cat alive or dead? And so quantum mechanics doesn't give you a straight answer. It says that the cat is simultaneously alive and dead. There's the wave function, okay? So how do you resolve this? And so there's something called the many worlds interpretation of quantum mechanics. And what it states is the minute you close that box, you have now brought into being two world lines off this one world line. Close the box, now I've got two world lines. And if you want to find out which universe you're in, you open the box. And sure enough, if you open the box and the cat's alive, by this model, you know that you've already brought into being a world line where that cat is dead. It's awesome. Okay. Yeah, it's kind of like that whole world line, right? There's a world line that brought me to Southwest Research. No, there's a world line that took me to the evil empire. That guy's probably happy. Or there's a world line where I'm still married to my second wife. That poor guy. Feel sorry. Oh. Now, again, you're like, well, is this a viable theory? Well, sure enough, Alan Aspect, the French physicist, he won the Nobel Prize in 2022. Again, the question is, can I measure these other parallel universes? Probably not. So the thing is, though, is it a viable theory? And it is a viable theory. They've actually used it over and over again. And actually, does anyone watch Veritasium? Look it up. Veritasium has a really, really good episode on parallel universes. All right. I'm going to try to get through this. I'm going to push on through. So this is another anime called Blue Submarine number 6. It's a 6-episode OVA from 2000. Here you've got a terrestrial threat. You have a scientist that's melting the polar ice caps. He's trying to eradicate humanity, and he's also mutated creatures that are made for living in an aquatic world. But, you know, humans, we don't give up. So what they do is they have this blue navy, and they attempt to stop Zorndike, or at least try to reason with him before, you know, calamity ensues. So I was watching this anime, and they talk about the Lorenzini system. So you've got this 10-year-old, so things must be really desperate if you have a 10-year-old basically as a warrior on a submarine, right? But she's the operator of this thing called the Lorenzini system. And I was looking online, and people are talking about the Lorenzini, oh, it's sonar. I remember back from my freshman biology that the ampullae of Lorenzini are actually electroreceptors. So I'm like, okay, well, how are they working? If they're an electroreceptor, well, what they do is they sense electromagnetic fields, propagating electromagnetic fields. This is how a shark hunts. You know, they always say that sharks smell blood in the water. They don't. They actually know you're there beforehand because of your electromagnetic fields. That's exactly what's going on. So, is it reasonable to assume? Well, how good is that? How good would it be to use radar as opposed to sonar underwater? So, if you use radar, you're using sound. It's got a speed of 333 meters per second at sea level, or 1,400 to 1,570 in seawater. You've got a certain frequency range. It's an active means of detection or navigation. It's kind of like when that bat. You guys have bats here? Yeah. Probably not like we have in Texas. I'll tell you what. We got some huge bat populations. But when that bat is squeaking, what's it doing? It's firing out, you know, sound, and it gets a bounce back, and sure enough. But it's an active means of detection and navigation, and you're doing measurements via what's known as a Doppler effect, this shift in wavelength. But again, the measurements are directional in nature. I think it's funny, when I teach the physics of superheroes class, we'll talk about Daredevil. And everybody thinks that Daredevil operates by sonar. And I said, wouldn't it be kind of strange if, you know, Daredevil's running around throwing his billy club and then squeaking at people to try to see what they are? And I said, no, it's radar. It's radar. Why? Well, the speed is much faster. Even in seawater, it's 2.54 times 10, 2.25 times 10 to the 8th. So it's still moving quite fast. You have wavelengths that range from meters to picometers. It's a passive means of detection, right? And it's also unidirectional. So it makes it, or omnidirectional. So it makes it a lot easier to detect these things. It's allowing you to see in the dark using light. Does that make sense? Well, I'm very happy to say that this was like the greatest Christmas present ever. You know why? Because this thing was the biggest funding hog in the history of mankind. Now, I'm gonna say it's a magnificent machine. It really is, okay? But this thing was getting all kinds of money diverted to it. So the James Webb Space Telescope was launched December the 25th of 2021. It is now LaGrange point 2. Why? Because it needs to be on the dark side of the Earth. Right? We're not worried about what's going on sunward. We want to see out. The operational temperature is less than 50 Kelvin. I'm sure my buddy Christian is on and he'll probably correct me later. But the observational wavelengths are 0.6 to 28 micrometers. It's seeing in the infrared. Why? It's because we were talking about these things. So not only the further things are away, the light from them is getting redshift. So when you're trying to look at the furthest reaches of the universe, looking in the visible portion of the spectrum is a wasted effort. You want to look in infrared because, again, even though those distant objects are emitting light in the optical range, as they are moving away from you, you are actually looking at light that's been redshifted. Their wavelengths are elongated. And so to see the darkest things in the sky, we have to use something that's made to look. And by the way, so since it looks in the infrared, all those beautiful images that you've been seeing, not the ones that are AI created, but all those beautiful images that you get from James Webb, you realize are false color because we can't see infrared unless you're Kryptonian. And if you are, I'm really jealous. All right, so this, Akira, this is the watershed moment. So those of you who get to watch anime on streaming services can thank this directly, okay? Because this anime made that whole, well, cartoons are just for kids, that whole notion went bye-bye. And even though there are a lot of what we would say more mature anime titles or anime movies out, nothing got the widespread recognition and distribution that this one did. So this anime kind of just set everything. Well, we got to talk about that motorcycle is iconic, okay? So I've looked at this over and over again. There's no visible drive chain, no visible gas exhaust. If you look at that one scene where he's skidding, it looks like there's electric discharges to the ground. All these things point to a bike being driven by rotating mass drivers, okay? Electromagnetic acceleration, and admit it, you want one. I want one too. I'm trying to get someone to fund me on this one. So again, mass drivers, also known as railguns, they use a magnetic field to accelerate particles to really, really incredible speeds. There's no exhausted products. They're very energy efficient. Magnetic fields only work on charges. So that means that you actually have to have a current. You have to charge this thing up and have the magnetic field work on it. It also means that you're working with magnetic levitation. Maglev is used with trains. Maglev is used with trains. We use it to either propel them or braking, right? You just change the direction of the magnetic field. Again, to make a motorcycle like this, you need an incredible power plant. But again, that's not what we're talking about here. We're talking about, are those principles properly represented? And the answer is absolutely. So, do we watch anime in order to, make sense of science? And I really hope not. Okay. Because if anime is your primary teacher, we're in a world of hurt. But and I use this. So when I wrote my master's thesis, it was an 89-page master's thesis on dark matter. And I was writing down these wave functions for these theoretical dark matter particles and their superposition of the superpartners of the. I was just like, you know what? I need to watch something. I was like, demons out, get out of here. So my buddy Albert, a mutual friend of mine and Aaron's, gives me the entire Bleach Soul Society arc on a thumb drive. I have like 3 thumb drives, and I binged that entire arc in a weekend. And I was like, thank you. Thank you so much. So, but I think it's important to stimulate the imagination. I mean, you know, we talk about someone like Einstein. Einstein's mathematical skills were considered, right? But what was his real talent? It was the fact that he used the mathematics in an imaginative way. The mathematics already existed. He just found an imaginative way to use them. And so, I mean, I think it's important to stimulate that imagination and always ask these questions. Is that possible? Is it real? Because ultimately, that's where all great discovery started, which is some question. Is that real? What did I just see? Can I make it happen? So I hope you enjoyed the presentation. Always ask questions. And do you have any anime that you want to recommend? I actually hijacked this. It's the physics of anime at gmail.com. Yes. Thank you very much.
If anybody has any questions, please raise your hand and we can run the microphone to you. Oh, goodness. We do have a couple online as well, and a couple of comments.
Hopefully, I'm just joking.
What does anime teach about dark matter?
Anime has never, to my knowledge, I know of no anime that teach anything about dark matter. And I'll be on the lookout. But I will say this, I don't know what I teach about dark matter anymore. When I was a young graduate student, I just knew we were going to find it. When I started at Rice, I knew we were going to find it. And as time has gone on, again, now we're 20 years after the fact, and I've gotten to the point where I'm kind of like that guy, you know, old man, cloud. That's where I'm at now. I mean, I started on the original xenon dark matter detector. It was 10 kilograms of liquefied xenon. They have now gone to, I think it's 4 metric tons of liquefied xenon. And the idea is if you've got a particle with a small interaction cross section, then you make your particle as big as possible. That's what they've been doing. And they're still using the same technology. I will be on the lookout. I will see if there's an anime that talks about dark matter. It might be interesting to kind of throw in there. Thank you.
I just wanted to say that online we had, just as the username, so it says the International Croissant Army says hi. And Billy Tringali says, let's go Roman. And so do you want to read the eggs?
So Eggs and Bacon says, if there are an infinite number of universes with different versions of reality, can it be argued that when we dream, our minds are theoretically looking outside the box into a different world?
That's of expertise. That's more of a psychology thing. But I mean, who's to say? I mean, who's to say that we don't? And here I go. I'm going to be the village crackpot. But I mean, who's to say that we don't have some sensitivity to things? I don't know. Again, the one thing that you normally hear, it's funny. You have 2 types of parallel dimensions. You have these dimensions that come into being when you have these events where there's like an A, B, or ABC type choice, right? But those are these dimensions that spring into existence at a moment. You also have kind of like, again, going with comic books, the DC type of universe where you have a whole bunch of parallel universes that simultaneously come into existence with one another. Those types of parallel universes are theoretically completely separated from one another. They essentially vibrate out of phase. And so a particle from universe A couldn't, interact with a detector from universe B. But these other, I'm trying to remember what they call them. These universes that kind of spring into existence. Who's to say? I mean, the laws of physics would still be the same. And then theoretically.
Oh, there we go. We have one from Ember Receiver who says, how far away would vehicles powered by electromagnetic acceleration be theoretically? How soon could we have things like cars or bikes powered by this concept?
That's question is the power plant. I mean, right now we have batteries that can take cars to 100 miles an hour, right? You could probably do the same thing with a motorbike, but the question is, you still have a bike wheel on an axle. What we're talking about now is a bike wheel that is suspended on a magnetic field. And that's going to require a lot more power. So decades. She wants to ask a question for sure.
For you, is there a point when the physics are just too unbelievable and it makes you not like the anime? So my part 2 of that is One Punch Man. What do you think?
It's so much.
Yes.
Again, the whole idea here is these anime have physics that are, just fine, but Neon Genesis Evangelion, let's throw physics out the door. Same thing with One Punch Man. I just love how crazy it is. There's another, all right, here we go. Has anyone seen, God, what is it? High School of the Dead, anyone?
Yes.
Okay, so there's that one scene. If you've seen it, you know which one I'm talking about. People have been wanting me to analyze that for the longest time. And I think I'm going to break down and analyze it, but just go look High School of the Dead and the scene, and you'll see exactly what I'm talking about. And you know which one I'm talking about. Yeah. No, I mean, again, it's the whole point. We watch anime, just like we watch anime for a lot of reasons, for the same reason that we watch the Marvel Cinematic Universe, right? I mean, I've been waiting for those movies to be made since I was a kid. I loved Captain America so much when I was a kid. I used to get a galvanized trash can, the old galvanized, and I try to bounce that thing off the wall. My mom used to get so mad, No, I mean, we do it to suspend reality, but I think it goes the same way with comic books. It's really nice to know that there are people out there who pay attention to the science, because I think in many ways, if you look at something like that, it does stimulate the imagination. It kind of gets you to ask those questions. Does that really work? I mean, I can honestly say that I think in many ways, my becoming a physicist is a direct result of my nerddom. That desire to watch anime, that desire to watch or read comics. It's just ingrained. Oh,
That one over here.
Attack on Titan.
Attack on Titan is awesome.
I have personally not seen it, but your opinion?
What?
What is it? Attack on Titan. Yes, ready? Yes or no?
Before you watch Attack.
I'm watching it.
All right, so I had one, but I'm not going to necessarily. This isn't a stump the physicist problem. I promise. This is more of a. We talk about this in terms of anime, and we try to talk about this also in terms of like comic world lines and things. I always kind of find it funny when you're going through a story and then it gets to the point where you can tell they've paid some attention to the science, but then they get to the point where it becomes a plot device so that they have to break the science. The line that I always come to is actually from the Flash TV show. The more you play around with time, the less the rules apply to you. Because Thawne and the Reverse Flash goes back and forth so many times that he just pops up wherever he wants to, even though he should have basically destroyed himself multiple times, because they have to use it kind of as a plot device where they kind of escape the bounds of, okay, what will physics allow and what will quantum mechanics allow for. Yeah.
So I remember, was it circa 1985, things in the DC universe had gotten just way too crazy. And they're like, well, did that happen on Earth 1 or Earth 2 or Earth X or Earth 5 or da 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 da? So Crisis on Infinite Earths, let's go ahead and smash everything into one. But apparently that wasn't good enough. So what do? Well, what sells comics? Parallel universes, right? Except these universes can talk to each other. Yeah, I think also, this is one of the things I'm actually doing a presentation at the American Geophysical Union meeting. So I have one where I'm talking about pure science, but another one I'm talking about physics as a form of outreach. Because, again, how do you make something more attractive? Because again, physics is soul crushing. I'm not gonna lie. Sitting in those classes like, oh, this is so much pain. But you can find a way to soften the blow, so to speak. And I think also that a lot of people, I know myself included, when I was reading these comics and watching anime, and again, I'm a first generation student. I was the first person in my family to go to college, and there was almost a sense of otherness that I would feel with respect to some of my family members. Like maybe somehow or another, I knew I belonged, but I didn't exactly belong. So you start reading comics and you read about like Reed Richards and Tony Stark and Captain America and Wolverine and all these characters. And it's like, wow, I can identify with some of the aspects here and identify with some here. And I think it allows you to get a sense of who you are and then the sense of the community that you're among. And I think that's something that's really, really important, not only as a comic book nerd, but as a scientist. What is your community? So, did you have another question? Or?
Yeah, we had one down here.
Anime seems to be a perfect vehicle to explore the hard problem of consciousness. Has this been done?
No idea. I have he's actually online right now watching. And his name is Billy Tringali. He's my co-author on that poster. And if anyone would know, Billy would know, because it turns out that there is something called the Journal of Anime and Manga Studies, JAMS. He's the lead editor on that. So he would know. Maybe he'll send me an email and I can get back in touch with you.
Other than the bike from Akira, what technology from anime are you looking forward to that is either close to or absolutely doable in the current timeline?
Gundam and Beam Sword. No. Well, I would like for us. We need to find a way to refine our propulsion, right? We need to find a way. I mean, if we're going to be really serious in exploring space and actually getting outside the confines of our solar system, we really need to bump up, one, our propulsion systems, and two, our communication, right? We need to learn how to like have buoys. We're still limited by the speed of light. Yeah, I mean, there's a number of things. I think giant robots in space is a way to go, though, for sure, right? Especially, if we're talking about doing work on the moon, right? Because they're talking about using the moon as an alternative launch platform. You're 1/6 the gravity, so the launch cost is decreased. I think that's something we really need to look into. Is you could make a giant robot that was functional on the moon a lot easier than you could here on the Earth. So that would be something nice to see.
Okay, so you mentioned the beam swords in Gundam, and that made me specifically think of Gundam 00, which because you mentioned propulsion, so that made me think of the GN drives, which is explored in the show, but I also am curious if you've watched it at all.
It's like I need to watch the presentation.
It's more thought out by the time of the second season.
Yeah, because somebody also recommended Albanoa Zero, something like that.
I wouldn't know about that.
So,
But
that email address, again, it's really physicsofanime@gmail.com. If you have any suggestions, because it's hard, I actually have to work from time to time. And I can't just say, what are you doing? I'm doing research. Yeah, so, if you guys have any suggestions, feel free to just fire them my way, because I'm always looking for more material. Anime is a changing medium, right? It's evolving, and one type of anime, isekai, is usually it starts to increase in popularity, and then it wanes, and then something else comes up. But I think it's a very nice vehicle because it is so rapidly changing, and it is so, I won't say new, but it's part of the zeitgeist now. Watching anime once upon a time was not really cool. Actually, comic books were cooler than anime, but do you realize now that manga actually outsells comics? Manga has regularly outsold comics for about the past 2 years or 3 years or something like that. So it's something that it's current and it's happening. So, which I'm happy about. More questions?
Well, hi, Roman. I'm also a Roman. I could have asked about the physics of things such as the fights in My Hero Academia and the way that most people should have their skin ripped off in the middle of them, but I won't.
There's passion there. That's all I'm saying.
Exactly. So if you can split the clouds, people aren't going to do well. But I was more interested in the theory of creating infinite universes every time you do any kind of action. I'm more interested in but in this case, it's more of a time travel perspective. If going back in time, you're also creating another universe where it's unsuccessful, another where you go back in time and it works, another time you go back in time, you get stranded. You're creating infinite universes every time you're using that time travel device. But what my real question is, what kind of echoes of energy do you think are spreading through space? Because that is energy that's creating more and more and more throughout all these infinite universes. Eventually, there's going to be some kind of collide or I guess cascade wavelength, and it's going to be a big issue, such as destroying a nebula or something.
This is the thing. Are a singular and parallel universes. Don't think of universes like being like right next door to each other. Like I need some eggs for my eggs, so I'm going to borrow them from my neighbor. It's not like that, and you'll hear people say, well, universes are going to bump into one another. These things separated. They're out of thing. And I mean, as far as energy, the amount of energy is the same amount that was back, and it the same amount of the universe, or the same amount at the eventual universe, right? That amount of energy is a constant. It's the density that is going. As we get more and more diffuse, we live in this very epoch where we can have structure and function and energy in certain places, but eventually it's going to get to the point where it's very, very diffuse. Even in that case, when we become very, very diffuse, the chances that we encounter another parallel universe, either I don't know, zero to none, very low, because again, they are separated in theory by some kind of phase. What it is.
So you mentioned how everything that is in the universe has always existed within the universe, and that reminded me of the concept of equivalent exchange in Full Metal Alchemist. And I need to know if you've watched that.
I watched both Full Metal Alchemist Brotherhood. Sorry. Talk about exchange. It's non-physical, but it's still, and I love how he rephrases it at the end when he actually.
I think it's quite physical. I mean, chemistry, for example, you can't have more than what you start with, and that's the entire idea of equivalent exchange.
So conservation of energy.
That can be applied as well. Yes.
Equivalent exchange. It is a conservation, and so it so I guess it's we're not dealing with we're dealing
Yeah.
with physical property. You could bring that up and say that it deals with conservation law. Talk about conservation of angular momentum, conservation of linear momentum, all of these things.
You mentioned that quote brotherhood is where it's at, which implies that you've watched the original 2003 anime. But have you watched the movie that finishes the story of the anime? Because that movie is
But
it has some interesting themes to explore, to say the least.
so I've Evangelion.
Yes.
So you watched the regular series all the way to the end?
I know there's multiple, but I just know that I watched the oldest one. Well, whenever you start a series, the most logical way to watch it is a release order.
It ended. People were so and then they actually had to make movies out of it. You know, that's
Well, I guess that's in the example of Evangelion, but for the 2003 anime of Full Metal Alchemist, that was just they weren't done yet, but they had to improvise. So they basically took a hiatus. It was originally supposed to be a season. Yeah. Okay.
Did we have any other questions back here? Yes, we do.
Short, quick question. You mentioned that light is or speed of light is a limitation on how fast information can travel. Do you think if we had a better understanding of quantum entanglement, we'd be able to and could harness that? That would be a workaround.
That would revolutionize. I mean, right now they're already using it as a means to secure communication, right? That's one thing they're looking at, those spin states. I think we need to look more at nature. So I don't know if you've heard this bit. They actually say that one of the photosynthesis is such an efficient means of energy transfer is because it is based on quantum entanglement. Photosynthesis is actually based on quantum entanglement. So, I mean, I think we really need to look at more physical systems, right? More biological systems, I mean by that, because somehow nature has figured out ways to do things that we're still just kind of scratching the surface of. But yes, if we could, I think if we could, quantum entanglement though would handle better your transfer of information. As far as a propulsion method, probably not. Yeah, I mean, it's kind of like when I ask my students about teleportation. And they're like, well, teleportation's instantaneous. I go, no. I go, you're digitizing yourself. You're turning yourself into some kind of photonic information. You're getting beamed to someplace, and then you're getting put back together. More than likely with the materials that are there. And so then the question I ask them, are you still you?
You had mentioned the propulsion being the one of the things we need to be focusing on. But what if instead of propulsion, it's opening up holes in space-time and being able to walk through those holes?
So there was this Spanish. So I think that's what ended up getting me to this point. The has this really, so when we do solutions in relativity, we have these things called metrics, right? So you've got the Minkowski metrics, which is flat space. So Alcubierre's metric has this interesting effect. It lengthens space behind an object in its direction of travel, but truncates space in front of it. because we're limited to traveling at the speed of light, right? An object, massive object cannot travel faster than the speed of light. Actually can't even achieve the speed of light. But what if you could introduce some type of mass, a negative mass, that actually truncates space in front of you and again elongates space behind you? This is his idea. You may not be traveling faster than the speed of light locally, so you're not breaking the law, but because you're moving through a space that's constrained, globally you're traveling faster than the speed of light. So yeah, people have been thinking about this, and it is mathematically viable. But the question is, where are you going to come up with this negative mass? No one's ever seen negative mass. No one's ever made negative mass. It could be dark matter, right? No, more than likely, if it were dark matter, we would have already seen this effect. Dark matter is another beast entirely that we blame for the large scale structure of the universe. So, I mean, let me close with this. The type of matter that you're sitting on, that you're made of, that you drive every day, that you interact with on a regular basis, that you receive sunlight from, that you can see, only comprises 4% of the universe. 4%. 23% is expected to be dark matter, and then the remainder is dark energy. That means I'm telling you that we know absolutely nothing about 96% of the universe. Would you say that there are employment opportunities in this field? I mean, and this is one of the reasons why I come out, and I'm really glad Aaron had me come out and talk, is because I know one day I'm going to take something called the big dirt nap. It's just the way it goes. And, you know, I want to know that there are still people that are going to be carrying on the fight, because that's exactly what it is. It's a battle. We're trying to learn more about the universe, and we need more soldiers. So hopefully my pointless rambling has maybe inspired a few of you to come and join the fight. So I think, oh, we have one more? Yes.
Have you ever tried looking into Astro Boy? Because I think it was an old anime, but it also became an animated movie as well.
When is this again?
Astro Boy. It's a science-based.
The original, you're talking about the OG.
What do you think about it?
It's amazing to go. You know, what's to say? I mean, that was like pretty much I think that was the first animated show. If I'm not mistaken, Astro Boy was the first one. Yeah, yeah. So I need to watch it.
Do you think the science is accurate for it?
Like I said, I haven't watched it and studied it for that scientific. Now I have to. So he'll ask me back.
She's got a question.
Could ask.
Your sister Letty is asking who your favorite superhero is.
Batman.
Which one?
And on Captain America. And on Marvel. So yeah. Okay. All right. I guess.
So we're gonna.
You know,
Sorry. Hold on. Here we go. So we're gonna. I will make the comments just because I told them that I would. So Billy Tringali did say great stuff, Roman. And Eggs and Bacon said thank you, Dr. Roman. I don't know if you've seen the anime Blame, but I just love technocratic dystopia. Have a happy Thanksgiving. But with that said, if there is anybody else who would like to come up and just talk with Dr. Gomez, he might hang out here for a few minutes to try to answer some questions. If you didn't sign in on the sheet up front there, that does help us kind of track how many people come to these free lectures. So it's just really helpful just to write your name on there. And then if you have like a SWOCC ID, that it asks that, but just anything on there just kind of helps us with that. We have a really great lineup coming up for our next term for lectures. So be on the lookout of that. I haven't quite announced that publicly yet, but we do already have 3 that are official and I think 1 or 2 more that we're trying to get on there. Again, thank you to everybody for coming tonight, and stick around and talk with Dr. Gomez if you would like ask some more questions. And if you leave here and you think about anything, my cards are up there. Just feel free to email me. I'll get you in contact with Dr. Gomez. And I will say that we do have a special event this weekend that I wanted to say a pre-congratulations to. And this being a physics lecture, Dr. Coiner and Cassie Trosper will be getting married on Sunday. So I want to say congratulations to you. You knew I had to say that. I was waiting till the very, very end. Dr. Coiner and I, he's my best friend. He's an amazing person. Cassie, I'm just so grateful for you guys to have found each other, and his family and everybody that's here to celebrate, along with Dr. Gomez as part of the family here too. So thank you again. Again, please come up if you've got any questions. Thanks.